Hi everyone. Today we will be talking about Meta's recently released research paper around large concept models. Since inception of ChatGPT, we have been hearing quite a lot about LLMs. Every week some large language model is getting released. But recently, if you have been following the tech news, some of the big tech guys have been quoting that the growth of LLMs is now plateauing, that it is not growing at the same pace at which it was going earlier. The intelligence is now getting restricted, and now we are hitting a saturation point. So what's next after LLMs? So this is to which Meta has given an answer, that is large concept models. So before we jump on to large concept models, we need to understand that if you must be knowing that large language models don't have actual intelligence, but they predict one token at a time. So if five words are given, they go with the probability of the sixth word. Now, in case of large concept model, it is not going with the prediction of just a single token, but an entire concept or an entire sentence. This is the change that has been brought into the large concept model. So basically, as you can read this particular point, a concept is defined as an abstract atomic idea. Now, this can be a paragraph, this can be a sentence, but it is not a single token. In practice, a concept can often correspond to a sentence in a text or equivalent speech utterance. This allows the model to reason at a higher semantic level. So basically, in case of LLMs, when you are predicting just the next token, it doesn't have the holistic picture. It doesn't have a semantic understanding of the entire context, what I'm talking about. But in case of LCMs, this won't be the case because now they are outputting an entire idea, an entire concept rather than just a single token. So if we understand with an example, traditional LLMs, the current LLMs that we have, if we give it an input, the cat sat on the dash, and the model will predict Matt, the last word. But in case of Meta's large concept models, if you give it the cat sat on the mat, it was a sunny day. Suddenly, the model predict a loud noise came from the kitchen. This would be a single output. It is not one by one output coming out. So your LLM might also be able to give the same output, but one token at a time. But in case of LCMs, this would be a single output coming out straight away. That is an entire sentence. Now, why it is very important? Multiple reasons. LCM is language independent, it is multi-model, and has a better for long form content. Makes sense, right? So, if you're writing a story, you would wish the LLM to output an entire idea rather than one token at a time for a better flow. Apart from that, as told, LCMs have been trained on all sorts of data, images, videos, text, etc., all together. Hence, they are language independent as well as modality independent as well. So, they can plan the flow of ideas instead of getting stuck on individual words. So, now LCM is not working on token level, it is working on an idea level. Now, giving you a key about the architecture of the particular model, let me show you an image first from the research page. So this is the high level diagram that the team has shared. On the right hand side, as you can see, we have having multiple words that are coming in a sentence, and which is leading to a concept encoder. Basically, it is accumulating embedding for everything and creating a single embedding for the entire concept or say a sentence. It goes through the LCM model and then concept decoder. So the only thing changing is instead of word encoders, the token encoders, we are now having concept encoders. Right, and this is a demonstration of how summarization task may look like, because as it is moving ahead, it is outputting the entire sentences, not a single token. So this is the input that goes in, and this is how the summary would have been generated using LCM. Just take a look, have a pause. We are not deep diving into the architecture a lot, as this would lead to a lot of confusion. Now back to our presentation. So talking about the architecture, I will just give you a short brief. The input text is first segmented into sentences, and sentence is encoded into a fixed size embedding, very very similar to tokens, where we were first of all encoding every token into fixed size embeddings. Now we are encoding every sentence into fixed size embedding using a encoder called as sonar embeddings. I think this is quite popular in the which has been released by Facebook. So you can read more about sonar. The LCM processes the sequence of concept embeddings and predicts the next concept in the sequence. So it is not just predicting the next token, but the next concept embeddings, as we saw in the diagram. The generated concept embeddings are then decoded into text to speech, producing the final output. Key points, I think, just to mention Sonar embedding space. Sonar is a multilingual and multi-modal sentence embedding space supporting 200 languages for text and 76 for speech. So it is a very diverse embedding space that Facebook has generated. Apart from talking about LCM, the large concept model that in the between that you saw in the diagram, it is usually based off diffusion or quantized based generation. So diffusion models, if you might be knowing, it the Meta team has tried out the diffusion model as well, or as well as quantized based generation as well. We are not deep diving into these concepts, and I think for now this is more than enough for us to understand what is the basic architecture and how it works. Now, the most important part of this particular example, the tutorial that you're following, how LCM is different from LLMs. So we will be talking about a few features. Talking on level of abstraction, as we have already discussed, LLMs works at token level, LCM works at concept level. Input representation, individual token, sentence embedding. LLMs work at token level, hence input is also token. In case of LCM, the input is sentence embeddings. Similarly, in case of output generation, LLMs generate tokens word by word. The text is generated word by word. In case of LCM, sentences are generated one by one. Language support and modality. LLMs are usually trained on specific languages. They are not trained on many languages, but in case of LCM, they are designed for multi languages and modality. Training objective, minimize token prediction error, minimize concept prediction error. I think you might have got the issue. Token and concept are the core changes that has been done, and rest of things almost remains the same. Reason and planning, implicit learns hierarchical reasoning, explicitly models hierarchical reasoning. Zero shot generalization. Compared to LCM, LLMs might struggle with zero shot, but LCM should be the way to go for zero shot generalization. Why? As we saw, they are using sonar embeddings and they have been trained for handling multiple languages and modalities. That's the case. Efficiency with long context. Compared to LCM, LLMs should struggle with long context because they don't have the concept, the entire context of what is going in a sentence, right? But this is not the case with LCM. They are now having a semantic meaning of the entire block, for example. Hence, in that case, LCMs have a better efficiency in long context. Application best for word level, best for sentence level. Flexibility limited to text based tasks. LCMs are not limited to just text based tasks. So that's the best part. Now you might be say that we have multimodal LLMs as well. So we can consider that too. But again, multimodal LLMs are also not very generalized that you can input anything and you get an output everything. This is not the case with multimodal LLMs as well. You might need to input just video and you would get a text or vice versa. So now concluding, I think Meta's LCM represents a significant leap in the language modeling. And I think I was expecting it for a very long time now because LLMs have been quite in the space for 2 years, and the rate at which the research has been going on, I was expecting something big to come in the LLM architecture change. LCM offer more abstractions, language agnostics, and multimodal approach to reasoning and generalization compared to LLMs. While LLMs excel at word by word tasks, LCM shines in high level applications like summarization, story generation, and cross model understanding. So, basically, for all the text related tasks that we usually do, and not just word by word prediction, I think LCMs should be the way to go. I think the model has not been released. If I'm not wrong, once it gets released, we can have a head-on-head comparison with the best LLM as well. By the time, I hope you read through the paper and understand more about how large concept model work. Thank you so much.